Natural Numbers Day 2. Essential question. How do you determine if a number is rational or irrational? Classify each of these numbers as rational, irrational, both, or neither. So we've got 4 circles on here. We've got rational, irrational, both, and neither. So we're going to take all these numbers on the left and drag them into the appropriate circle on the right. Now you can start wherever you want, whatever one seems easiest for you. I'm going to start with pi, because pi is generally easy for people to remember that it's irrational. If you type in pi on your calculator, you get 3.1415, and it continues forever, never repeats, never stops. The other irrationals are the square root of 13, because that is not a nice square root. We'd also have this decimal because there are not any numbers that repeat in it, 2714. We have the dot, dot, dot at the end, meaning it continues forever. Now this decimal also has the dot, 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 but it's always the same number. So that means it is repeating. The 5 is always repeating. Repeating decimals are rational. 0 is rational. 3,000 is rational, because it is a whole number. 3 1/2 is a fraction, which is rational. Square root of 9 over square root of 16. Well, the square root of 9 is 3, and the square root of 16 is 4, so that means it is 3/4 as a fraction, so that is rational. If either of those square roots would have been a non-perfect square, then it would have been irrational. 7.24 is just a decimal that stops, so it's rational. Square root of 64 is 8, that is rational. Negative 4.5 is a decimal that stops, that is rational. Now you'll notice that there is nothing in the both circle, there is nothing in the neither circle. In algebra, you will never learn any numbers that are both rational and irrational, and you will never learn about any numbers that are neither rational or irrational. So if they ever ask you that on a test or on Study Island or on your MCAs, they're trying to trick you. Kind of like the Study Island topic with the linear, nonlinear, you can't have something that's linear and nonlinear or neither linear or nonlinear. It has to be one or the other. All right, put these numbers in order from least to greatest. So, I think when you're ordering numbers, the easiest thing to do is to turn them all into decimals. So 4.3 can stay as 4.3. Pi, we all know, is 3.14. So maybe I'll make a little squiggle in between these so we can have space. Okay, square root of 8. Now we've got to go back to that square roots lesson with the number lines. The 2 perfect square roots on both sides of 8 are 4 and 9. Square root of 4 is 2. The square root of 9 is 3. So that means that 8 falls between 2 and 3. 8 is closer to 9 than it is to 4. So I'm going to say maybe 2.8. 16 divided by 3. 16 is my numerator. My nerd goes inside the house. My denominator, the 3, the dog, goes outside. 3 can go into 16. 3, 6, 9, 12, 15. 5 times. Bring down the 0. 3 can go into 10. 3 times. And so on. So we'll leave that one at 5.3. And then we have negative 2. Now the important thing when you're ordering is we don't want these listed as our order. We need the original numbers. So my smallest one is the only negative, which is negative 2. Oh, excuse me, we want greatest to least, so I got to make sure I read my question right. The greatest one is 5.3, which was the 16 over 3. And if it helps, you can cross them off as you go. Next biggest is the 4.3. Then we have the 3.14, which is pi. Don't write 3.14, you gotta write pi. Then we have the 2.8, which was the square root of 8. And last we have the negative 2. Now don't make the mistake I did where I started going from least to greatest. You've got to go what the directions say, greatest to least. It could be one way, it could be the other. That's why you've got to read carefully. What kind of numbers are included in this set? Rational, irrational, both, or neither? I think the easiest thing to do is to classify each number so then we can see. Well, pi is irrational. The square root of 4 is 2, so that's rational. Square root of 11 is not a perfect square, so irrational. Square root of 7 is not a perfect square, so irrational. Square root of 16 is 4, so rational. So in this set, yes, we have numbers that are both irrational and rational. Now remember I said if you're looking at one number, it can't be both. But if you have a set of numbers, yes, it can be both. So this set of numbers has both irrational and rational numbers. Select the correct symbol to fill in the square. So you should recognize these symbols from chapter 5, greater than and less than. So now we've got to figure out what each one should be. Well, pi, like we said, was 3.14. I'm repeating. Square root of 9 is 3. So that means 3.14 is bigger than 3, so I'm going to put a greater than symbol in there. Square root of 11, let's find out what that should be as a decimal. Well, my smaller square root is 9, my bigger one is 16, so it's somewhere in between 3 and 4, closer to 3 than 4, so let's say 3.3, and then we have 1.75. 3.3 is bigger than 1.75, so I'm going to put a greater than symbol in. Square root of 5, the two nice square roots on both sides are 4 and 9. 5 is closer to 4, so it's going to be closer to 2 than it is to 3. So I've got 5 and we'll say 2.2. 5 is greater than 2.2. Lots of greater than so far. Square root of 31, well, we've got the square root of 25 and the square root of 36. So kind of right in the middle. 25 is 5, 36 is 6, so we'll say 5.5 and 53. 5.5 is less than 53, so there's our first less than. So greater than, greater than, greater than, less than. Which of these statements is true about 10 times the square root of 13? It is an integer, it is rational, it is irrational, it is neither rational or irrational. So if I have 10 times the square root of 13, 10 is rational. The square root of 13 is not a perfect square, so it's irrational. No matter what, a rational times an irrational is irrational. If you want to make this little key to the side, it might help you. Rational times or divided by rational is rational. Rational times or divided by an irrational is irrational. And an irrational times or divided by an irrational is always irrational. So the only time you end up with a rational is if both numbers are rational. 13 plus the square root of 60. Well, 13 is a rational number. 60, square root of 60, is irrational. So no matter what, if I have an irrational and a rational, my answer is always irrational. No matter what operation you're doing. I think I mentioned multiplying and dividing on the last slide. Same for adding and subtracting. Summary. Your homework for this lesson is the Study Island worksheets. This would also be a great time to do the real numbers, or I think it's called rational numbers, Study Island topic.